A warm welcome to everyone. Here we are going to discuss about the designing of an half adder circuit. An adder is a digital logic circuit in electronics that is extensively used for addition of numbers. With the help of half adder, we can design circuits that are capable of performing simple addition with the help of logic gates. A binary adder circuit can be made using two gates. One is the XOR gate and the second one is the AND gate. The summation output provides two elements. First one is the sum and the second one is the carry. In half adder, we can add 2-bit binary numbers, but we can't add carry bit in half adder with the two binary numbers. Below is the block diagram of the half adder circuit, which requires two inputs and provide two outputs. Let us consider A and B as the two input and sum and carry as the two outputs. This is the binary addition of 2-bit numbers. Since there are two inputs A and B, it can take values of 0 and 1. The total number of possible input combination is 4. The first column represents the first bit or digit, the second column represents the second bit or digit, and the third column represents the sum of the total, and the fourth column it represents the carry. If we add the first bit and the second bit, that is the input A and B, that is 0 and 0, the sum will give you 0 and the carry is also 0. If we add the input A as, if we consider the input A as 0 and the input B as 1, if we add 0 and 1, the sum will be 1 and the carry will be 0. If we add the input 1 and 0, the sum will be 1 and the carry will be 0. If we add 1 and 1, the sum will be 0 and the carry will be 1. Now we are going to see the construction of an half adder circuit. We have seen the block diagram of the half adder circuit above with the two inputs and the two outputs. We can make this circuit using two basic gates, that is two input exclusive OR gate or XOR gate and two input AND gate. First, let us discuss about the two input exclusive OR gate. This is the symbol for two input exclusive OR gate, and A and B represents the two input, and this represents the sum output for the exclusive OR gates. Similarly, we can use the AND gate for the carry bit for the same input A and B. This is the truth table for the XOR gate. Here also, since we are having two input, the four possible combinations are 0, 0 and 1, 1. So we are taking the first column as input A, second column as the input B, and the output as the sum output. Here, when we XOR 0 and 0, the sum out is 0. When we XOR 0 and 1, the sum out is 1. When we XOR 1 and 0, the sum out is 1. When we XOR 1 and 1, the sum out is 0. Here we should note that in XOR gate, the output, sum output is high only when any one of the input is high. If the input, both the inputs are in the same combination, either in 0 or 0 or as 1 and 1, the output goes to the 0 state. Next, we are going to see about the two input AND gate. This is the basic circuit of two input AND gates, and this output produces the carry output. The output depends upon the truth table of the AND gate. This is the truth table for the AND gate. Here also we are having two inputs A and B. So we are having the four possible combinations for the inputs. Here if we AND 0 and 0, the carry will be 0. If we AND 0 and 1, the carry will be 0. If we AND 1 and 0, the carry will be 0. If we AND 1 and 1, the carry is 1. Based upon this, these two gates, we are going to construct the half adder circuit. This is the logic diagram of the half adder circuit. It is made up of the combining the XOR gate and the AND gate for the same input A and B. Here the XOR gate produces the sum output and the AND gate produces the carry output. This is the Boolean expression for the half adder circuit. The sum output is got as we seen from the XOR gate. So we are XORing A and B with the XOR gate, and the carry output is got from the AND gate. We are ANDing A and B with the AND gate. This is the truth table for the half adder circuit. The first column represents the input A, the second column represents the input B, and the third column represents the sum which we got from the XOR gate, and the fourth column represents the carry bit which is produced by the AND gate. When the input is 0 and the input is 0, we get the sum as 0 and the carry as 0. When the input is 1 and the input is 0, the sum we are getting it as 1 and the carry is 0. When the input is 0 and when the input is 1, the sum is 1 and the carry is 0. Similarly, when the input is 1 and when the input is 1, the sum will be equal to 0 based upon the XOR gate, and it is equal to 1 based upon the AND gate. With this truth table, we can easily identify or we can express the half adder circuit. Thank you.